Okay, great. I've got enough folks here. Let's get going. First, we have one new person attending, and hopefully we can keep her interest. So,
Hi, I'm Veronica. Nice to meet you.
Let's see. Veronica. Veronica. Is that right?
Yeah, just Veronica.
Yourself and get audio.
Okay, just Veronica.
Oh, wait a minute. Maybe it's my sound that's off. There we go. Sorry. My bad. Whoops.
One more try. Okay.
Okay, yes, I hear you well.
Okay, perfect. So nice to meet you. I'm Veronica from Krakow. It's written differently in Polish, but it's Veronica.
Veronica. Okay, great. Just a little bit about your interest for the group to know, and you'll meet everybody else as the time goes by.
Okay. Yeah, so I'm working with Agnieszka Wawrynowicz on the project when we want to provide logic-based substitution methods and also machine learning-based, but I'm more on this symbolic AI side. So I've been working with ontologies and logic programming, like Prolog or answers to programming. And yeah, I've done my PhD on ontology-driven information extraction. So
yeah. All right.
These are my musings since 14 years now. And now I'm into food, so we are working on knowledge graphs within this domain. So hopefully I can be of use or can contribute.
Great. All right. So I just want to note one other thing this week, which was kind of our joint food ontology work group has a little bit of a mission statement up top, but this particular group doesn't. So if you guys could contribute thoughts to what a mission statement would be, I just kind of put down in a sentence what I thought it might, what the unifying factor of us meeting might be. And I'll try to massage that in the coming week or two. You guys also want to put your input in there to make sure that your interests are covered. Without further ado, then, I will get into today's meeting aim, which is to introduce OBO Foundry process modeling, a review of it.
Damien, maybe just if I may, can I add just a couple sentences of preamble for us?
Yeah, sure.
Just as a sort of warm up and a reminder for those who were with us last time, and sort of update for those who weren't. So what we said as a group was this is going to be a group that gets stuff done, right? And we were excited about that. But we also said, oh, and in order to get things built, we need to align on some big ideas, sort of so-called foundational ontologies, and then we'll have a basis, a foundation to do things that are a little bit more, in subdomains, be they on fermentation or on packaging or what have you. And I think there's a lot of alignment around the importance of that sort of foundational time. We don't want to spend a year on it, but it may take a few sessions for us to sort of digest even just the thinking that's been done over the last 6 to 12 months in this area. So we set up for starters, 3 sessions to learn about OBO, to learn about PO2 transform-on, and to learn about some food-on analysis on processing process types. And this is the first of those, which means that we're not going to be in a position right now to sort of vote up or down, right? Or even really totally grapple with this part that Damien's going to present, OBO Foundry stuff. But we should be expecting that this is, a proposal as part of the foundation for what we're going to have. So we should have opinions about it. We may have some initial thoughts about how it fits with other things. We should anticipate a little bit of dialogue about it today. But it is also largely an absorbing session for us. And we should expect there's a couple of these coming so that then we can really grapple together with, all right, what does it really look like for food on, and maybe for some other places. that's the sort of spirit of this meeting, I think. That sound, I see Damien nodding. Does that work for everyone else still?
It does for me. And I have been writing down things about what how I view process and procedure. So
Me too, Diane. I think it's useful for us, all of us, to be always testing any of this against our, our expectations, our sort of hypotheses, and that'll also give us a little bit more pointed questions, right? More productive interaction as we're going, instead of just like, I'm just here to listen. So cool.
Yeah, and some of it comes from Six Sigma work that it's been done in manufacturing, including cars and other things. So, it has the quality controls, it has, all the different pieces built in. As far as that'll be my other test, will be some things from the manufacturing world.
Nice.
Because we're doing food processing, a lot of that I think is in the supply chain and manufacturing. And yeah, and I was in container shipping for 8 years as well.
Right. Well,
I'll let Damien go on with his thing, and maybe
Right.
Troy we could get together offline and compare notes.
I appreciate the high level thinking, and then the technical nitty gritty. Hopefully I'm flying in fairly low on the technical nitty gritty to lay the framework. So appreciate all of you for that. Different levels of thought. Okay, so OBO Foundry process model. The distinction, today's show is about the syntactic side of it. And then I think Magali's would be half syntactic and half content. And then the Tarini and I paper will be all about content, structural content. And what I mean by that is ontology in today's show is just going to try to provide the relationship and general classes, domain and codomain structure. And this is all in support of knowledge graphs about detailed information about process modeling. But and so we're going to be covering the relationships in the OBO Foundry model and the generic classes like information and material entity at either end of those relationships as inputs and outputs. And then both of those things are used to create the sentence structure in the OWL world. That's a triples, little mini sentences of triples that populate a knowledge graph. But the content side gets us into a discussion of what are the actual material processing classes, and what are the necessary variations on relationship that need to handle that detail in food processing. So I'm not going to touch on the content. That's mostly the next two presentations. Now I will say a word about the general OBO Foundry framework, and BFO backs this up, or this was the inspiration for it. So we can't say process ontology provides a transformation relationship glue that explains time-slice views of the world, and also for data generated about the world or itself. So this is just a general BFO OBO Foundry framework where the vocabulary or ontology layer sort of illustrated the upper layer of this diagram, these vertical slices, starts off in the material world as a slice of material entities and their classes. And then we've got processes explaining the change between one slice of the world and then a transformed material, also using the same vocabulary in terms of describing things. Of course, how do you describe things? You describe them with the qualities or characteristics of those things. We can also talk about characteristics of processes. Most of the work in process modeling is around the characteristics of things transformed, and regenerating information about those observations about those characteristics. So that's the statistics and other analysis of collections of things and individual observations. And then there's also a layer of identifiers that are perhaps even more abstract, tracking things over time. So down at the data instance layer, we've got the assertion box, and that's what mostly ends up in the knowledge graph, assertions about exactly how to cook something or boil an egg. So I'll just touch on this, and then we're going to dive into the actual relationships. So one of the topics is about what's the general structure of OBO Foundry process modeling. It has to do with material entities that are inputs to processes, and those processes have outputs. And those outputs can be either material entities or information. And material entities certainly have characteristics that can change as a result of transformation. But a lot of times you'll go out into the world and you'll see an object-only model. Some ontologies just focus on the objects, the slice of time things that you can see. So they'll just do a shortcut kind of relation derives from, say, to explain how one material entity derived from another. And that's hiding all of the transformations, process modeling, and it's avoiding that. And between material entities and information, another shortcut is about, doesn't say exactly how that information was derived or measured, in what way it's about it. It's just a real shortcut. So, and then other times you'll see just a process-only model view where one process gets input from another. So you're just seeing the chain of dependencies between processes. And there's a shortcut for that. Directly provides information for, or provides input for. So just to be aware when it is we're actually looking at somebody doing process modeling and when they've taken shortcuts of some kind and avoided the complexity of modeling. Of course, what would be really neat is to create a system that has the detailed process model and then allows you to press a button and get either the object-only model or the process-only model out of it. So that's certainly a name of mine.
It's a name of mine too.
Okay. So, and, oh yeah, and by the way, everybody's free to interrupt. I don't mind that at all. It helps me. It helps me understand what needs more talk. Okay, so now OBO Foundry has this basic process entity, which is by default, it is in the upper level class above something we'll talk about, which is planned processes. Unplanned processes are basically things that happen in the world, but there's nothing guiding them other than the natural world's assembly of events, materials. So it's biological, chemical reactions, physical things falling, apples falling from trees. These are unplanned processes, which fit under the general class process. And they have inputs, material things, and outputs, materials. And at the very least, they would have some kind of time that is occurring, a duration across which they happen. Now, two notes that are coming up here. One, I mentioned this COB here. So this is the core ontology for biology, which is what OBO Foundry is trying to move towards. It's a sort of simplified version of BFO. It just has information, process, material entity, immaterial entity at the top of its hierarchy, although it is trying to logically keep those categories separate. So there's some amount of the BFO logic.
Damien, sorry, just a question. Is this from a model, or does this exist in OBO? I'm a little lost. Sorry.
Right. So in OBO, there are a couple of ontologies that are brought together to create this process model. OB kind of spearheaded it. Yeah. But for example, Chris Mongal, when they're doing, I think, the gene ontology, think they came up with has input and has output. These are slightly different from OB's has specified input and has specified output. But the general, and so capable of, part of, and capable of, those are one of the ontologies in OBO Foundry is providing those. RO, actually, RO is relational ontologies providing those.
Okay.
Yeah.
And then this is Diane, the work I'm doing, or I actually did major in chemistry in college, but to me, a chemical process or a biochemical process or physical organic chemistry, there's a process and there's a trigger, there's potential energy, and you got to set that up, because a lot of things, even if they happen in nature or in a computer system, they still have triggers and things that align up to cause them to happen.
Yeah.
And processes can have duration and maybe triggered by certain time events, like, beginning of spring, or, some things that have characteristics in the natural world. And sometimes it's like, well, it's May, except if it's cold, or it's this, except,
So Diane, I'm going to get into all of this, and
yeah,
let me roll, and then we'll get into a longer
perfect
discussion of these things. Great. Okay, so this is a basic model. Now, the thing that isn't part of OBO and COB officially is this time has time, using OWL time to describe time. So I'll get into that a bit too. So fermentation you can find in gene ontology, and there's some, I think there might be some process stuff around that or not. I can't remember. Anyway, this is the real raw bones. There's some ability to distinguish material entity inputs into a process by saying that those material entities have a certain role with respect to the process. And so you can add roles onto this. So that shows up soon. Okay, so the crash course in the planned process, which is one step down from the subclass of process, is one that starts to introduce things like negatively and positively regulates characteristic of a material entity, some quality. So you can have a process increase the temperature or decrease the temperature of something, just a relative, a claim about the relative change in a characteristic. So COB, the one additional complexity COB gets into that OB didn't, is that in OWL land, you can say that a planned process exists. That means it completed, but COB has some facility for processes that didn't complete. So you'll see that in that hierarchy when you put it up. All right, so let's go look at some other relations. So what distinguishes planned process from process is mainly this plan specification. That a planned process executes a plan specification, and it has objective specifications and action specifications. The distinction between these two is explored in a month with Turini and I's little paper on that. At any rate, we do use those to guide, to determine when we know a process has successfully completed. So there are ways of expressing those objectives. I'm not going to get into them today. All right, so the OBO model has some facility for describing process dependencies. A planned process can be a part of or has component process of another planned process. And there is also an ability to say a planned process is immediately preceded by, or just preceded by, some other process. So that helps with abstraction a bit, but there's more to explore there. Now, this is the add-on. There's some facility for describing time in OBO directly, but it was sort of never really formalized with respect to a process. There was a duration, but not much language, not much ability to get into the details of how to describe durations and so on. So for that, I am pushing, and others are also pushing, to implement OWL time in some way into OBO Foundry officially. Yes, Magali.
Just a little question. Why don't you have the RO ID? Well, you don't have for you sometimes you have specified the RO ID and sometimes not. Does it mean that there is no RO relation ID so far, or why do you?
Oh, why do I have?
Did you not mention them?
Right. All right.
Sorry.
It might be a bit inconsistent in my diagramming here. Just to say, any one of these labels you can look up to get their ID in OBO Foundry, LS or OntoB. They are almost all from the relation ontology. Yeah, I probably put it in as a note so that I could quickly hyperlink to that. If you'd like, if this is a vote to actually add the IDs in one diagram, at least for easy reference.
No, it was just a question to be sure that
okay.
The relations already exist or not, because I was just wondering why. It's no
Gotcha.
problem.
They all the relations I show exist except for some discussed later on. All right, so this model plan process isn't just about transforming material entities. It can also take in data and output data, and that's called a data transformation. One can imagine a computer program stuffed with data transformations. So that's there. And an OB assay, the assay is a mighty class in OBO Foundry because it's taking on all cases where a piece of equipment is making observations of a material entity and generating a data item out of it. So there are thousands of assays listed under that class in OBO Foundry. And technically, agricultural IoT devices would also be classed under assay. So it's a little bit awkward at the moment to consider all those kinds of processes under the Ontology for Biomedical Investigation assay class. So maybe it will move to COB, I don't know. Okay, next up. Processes are capable of being executed. That's not quite the right word. Devices are capable of all of, or at least enable, I think that's the dedicated to, enables is dedicated to a planned process. This is how you can say a particular device is associated with a process, and the word utilizes allows it to be into a material entity. Of course, people are running these processes in some fashion. They're responsible for them. So we can talk about agents being robots or human operators. And you can talk about the roles of those agents. So there's language around that in the relation ontology. So altogether, as of a year ago, I was put this diagram together to have them all happening at once in one screen. And this diagram is now online in a Draw.io diagram, which is linked from the slide there. So people can actually go in and view it. We've added a few things that I've even learned. So for example, I didn't recognize that there was an RO relation between a planned process and a material entity called has intermediate. And this is some material that's in the middle of being transformed by that planned process. So that could be useful. There's some new language that COB is introducing around a planned process intending to realize the plan rather than always realizing it. So we can start to talk about processes that we're working on now or in the future, modeling those in knowledge graphs.
sorry, what's the difference, Damien, between the plan and the specification?
Right. There's some sort of fuzziness around plan. Plan is some sort of notion that one is going to actually do something. Plan specification is a piece of paper or digital file, a document, a piece of information construct that outlines all of the protocols, the objectives, the specifications. So it's a lot closer to an actual document or computer agenda itinerary.
Okay, got it.
And you'll see that just about always people in OBO Foundry are just working with plan specifications if they reference anything, and there's notes about the vagueness of plan.
And just to go on this point, why is there two names of the arrow from plan process to plan specification? Is it realizes or concretizes the
It's both. So
both? Okay.
there is
it is the same, or it is
there's
a mixed.
There's debate right now. There's a few people that don't want a realizes concretizes property chain. It's esoteric stuff about the difference between information and when you're dealing with...
and realization of a plan. Yes, yeah, there is the plan and there is a realization of the plan, I guess.
Yeah.
Okay.
I know. So even I get lost in that discussion. So guess what? This is why Cobb executes is the relation to use from now on, and it avoids all of this other stuff. So
I think the plan is the way that my dish is supposed to come out. The specification is the cookbook I use, and then there's the realization, which is the gross thing my wife has to eat.
Mm-hmm. Humor will carry us through this morass a bit. Yes.
Yeah. Let's keep going.
Okay. Anyway, executes is the way to go in terms of the link. Okay. Yeah. So this topic of shortcut relations, the picking apart of all these pieces. I just wanted to illustrate one or two shortcut relations and the potential for them. So we may have an OB assay that's got a specified input of some material entity and it's outputting some measurement datum. And that measurement datum is, we can say it's about some characteristic that was measured by the assay, and it's a characteristic of the material entity. So you can imagine a knowledge graph with all those pieces in it. But what if we just want to avoid even mentioning assay? We want to make a link. We can't remember how something was measured. The spreadsheet we're looking at didn't even bother to say what analytic tool was used. All we know is we have a measurement datum, and it's should be connected to a material entity in some way. Well, perhaps we've modeled out that the material entity has a characteristic and the measurement datum is about that characteristic. And then we've got, whether it was its weight, characteristic was weight, and measurement datum was a value. It could be categorical, heavy, light, overweight, or it could be numeric, 190 kilos. So we're making a distinction in measurement datums, what they are, so we can keep them in the process modeling fabric matrix without necessarily saying what their values are. That's one move. And then the second is we're using general language to say what those measurement datums are about. It's about some characteristic. It's about some weight. So we could reference in our knowledge graph two triples. Material entity has characteristic, some mass, and measurement datum is about some mass, and then its value. And that would be the sentence structure for capturing that. But should we have a shortcut that a measurement datum is about the material entity? After all, it is in a sense about it. This assay generated some information about that. So whatever it generated must be about it. So we could use the is about relation to connect measurement datum to material entity as well. That's allowed, but it's vague. So the question is, when do you start adding shortcut relations for convenience in your knowledge graph? So I'm just throwing that out there, but you'll see we have these choices about how much to add or not, and what can be worked out from what.
I think some massive chunk of our challenge here is shortcut engineering.
Yeah.
How many do we need and want and why?
Yeah.
Totally
Yeah.
yes to this.
Yes. And I will get around to some explanation of that towards the end of it. I mean, my own thoughts. Okay. So just to say how these things weave together. So why aren't we just, in OBO Foundry, just saying has ingredient and keeping that in the food ontology? Why aren't we just having specific relationships that spell out exactly what we mean and not bother with all of this concern or slow process of curating what a term might mean generally and in other communities? So here's an example of how the process modeling language is used in a demo knowledge graph, talking about a patient, Homo sapiens, an instance of one who's tracked by an identifier. They went into the doctor to get a diagnostic process, and part of that was an assay. And it was an assay that contributed to a specified output at the diagnostic process level of some diagnosis, the papillomavirus infectious disease. That's what the diagnosis is about. And the additional piece that seems to be that disease inheres in the patient. So this is all using the general OBO Foundry language. It's not, there's no has disease, patient has disease relation here, but there could be. But if there was in somebody else's knowledge graph, how do we map that over? So we need actually a lookup set of expressions that transform for any given relation from the world, what it actually means in our, what I would call rock bottom semantic, at least aspirational rock bottom semantic knowledge graph representation. This is the only way we're going to be able to map knowledge graphs from all of these different communities together, is by hitting rock bottom semantics. So this is just illustrating how the hierarchy of these of the context of OBO Foundry family of ontologies provides so much more intelligence about what it is we're dealing with semantically with each of these relations. Notice how we immediately get into the semantics defined by the classes rather than trying to have opaque semantics in the names of the relations. So it tops out at BFO here, although with COB, it's actually topping out at BFO doesn't actually top out at material entity. It keeps on going. But here, this is actually reflecting kind of COB for material entity process. And then characteristic is happening, or information and disease is a kind of characteristic in COB. Okay, so seeing this at work a little bit preliminarily, there's some stuff in Foodon. There's some of these processes that I did pop in there just to justify this slide at a hackathon a couple of years ago. So we do have these Foodon terms, and they are connected by these relations. Grape destemming process actually does output a grape whole, some output, and grape crushing has a specified input, some grape whole, and leads to some grape juice as one output and destemmed grape must as another output. So multiple outputs, defining them by their class. And so you can add all sorts of qualities onto these classes and so on. Any questions so far about that? Okay. just as a side, I don't have time. Side note, there's confusion in the literature about how to name certain things. And so that this slide also shows that too. Okay, so last year's process paper really got into the nitty-gritty of how this might be used from an OBO Foundry perspective, how we might model boiling a carrot using these generic relationships. Second iteration on this is called for, and it'll be a little bit simpler, but suffice to say, you can talk about ingredient lists or sets that have members, drinking water, prepared carrots, and devices being cooking stoves and containers, and the processes, the steps of adding, the process is devoted to adding water into the container to create an output that's water in a container, and then heating that container and so on. Yeah. So coming towards the end here, so owl and identity is one thing that sort of throws people. Say I'm boiling some water. Can't I say that that water is the same water on the outside of the process as on the input? Surely it's the same water. Well, from an owl perspective, technically, no, it's not. This water was at room temperature, and this water is molecules at 100 degrees or 200 degrees Celsius, 100 degrees Celsius. Is that right? Yeah. And so they're not equivalent. They cannot be the same thing from a logical perspective. So I actually have to say, well, this output water of the process, the only way I can refer to it is by giving it an identifier of some kind, referencing that this instance going into the process and this instance coming out are accessible by the same identifier. There are other ways. There's another way of doing that too, possibly more complex ways. When we get into them. Okay, Troy.
The instance itself has to be different, but the identifier, the food on ID, does not need to be different, right?
We're not talking here at the food on ID level. We're talking here at knowledge graph instances of classes of things.
Good. Okay, I'm with you.
So this container will give it an instance N92. And then this container over here, because it's grabbed from another module, say, might be N94 instance. And
I'm with you. Okay.
And our identifier is I927, and that's pointing to both of them as being part of the same knowledge graph, once it's all put together. I haven't really worked on this other than knowing that this has to be the solution to tying these things together.
Okay.
And I'm synchronized with Troy because I have also a question, because I don't really understand what you mean here by, I understand what an instance is, but I don't know why here you don't have the type. How do you use the ontology classes?
Right.
I don't really understand, why you don't see here to what classes the instance is attached to.
Okay, so this dotted line means this is an instance.
Yes.
But it's referring to class IDs here.
Yes.
So that's meant to be shorthand for, this is an instance with whatever ID it has. This container could be X192. Its type, it is instance of OB container 967.
Okay. And what you are talking about is that you can have different instances with different IDs, but in fact, they're refer to the same type.
Yeah.
Same class.
Okay, same class. Okay, thank you.
Yeah, we have to say this container that this drinking water is located in has a different ID just because of OWL logic. OWL logic will, it may look like, well, let me use the drinking water as an example better. this Howell drinking water here, which is at 100 degrees Celsius, is definitely different from this one. So the only way we can say that this track them is by giving them both an ID, an instance of an ID.
Damien, sorry, is the second drinking water you just pointed at, yeah, that one, is it at 100 degrees because it's a result of the process adding liquid to the container?
Right, so that's 200 degrees, is that right? Oh no, oh right, sorry, I'm ahead of myself. It's the boiling water one that's at sorry, 200 degrees Celsius. I'm always forgetting whether it's 100, 200 degrees. This
yeah,
one,
yeah, it's 100, but it's the
that's right. That's right. So the reason why this has to be separated in the drinking water case, where it seems to be the same stuff. This is the same pot. This is the same water, but the water is located in the pot. This wasn't true before going into the situation. So this is a little drinking water located in container that would be violated OWL logic-wise, identity-wise. There would be a contradiction here between not located in, this drinking water not located in container, and drinking water located in container. These two time slices are contradictory. So therefore we have to keep them apart with separate identifiers. And then over here in the boiling water, yes, there's an actual change here. It's not just the located in, it's the temperature of this water that's changed. Okay, next. So process abstraction. This to the earlier point, Troy, being able to have a detailed process model. But hey, what if I just want the ingredient list of all the ingredients in a recipe, even though there are several sub-processes that use certain ingredients? So I want to be able to abstract up to the main process, cooking minestrone, minestrone recipe process. I want to abstract the ingredient list. So we're looking for a transform, fetches us all the ingredients. And I think we can say that indeed all those subcomponent ingredients are ingredients in the main process. And there's also this causally related to, directly provides input for a relation between the processes shown here. Yeah, there's opportunity to really grill this kind of thing to see in which case we can actually automatically understand that all these materials are ingredients rather than intermediate products of, because you'll see lots of intermediate products mentioned as well, possibly in the process. And then in terms of process control, here's an example grabbed from the presentation in a month. Food processing by sensory objective can have a food processing of some kind, boiling rice, and then some kind of sensing process that outputs information in an assay that goes into some kind of decision process that generates the Boolean, stop cooking. This is all sort of on paper, but I haven't logicked it out and come up with any terms around classes for decision processes. But once we do, or once we start playing with this, is this in fact tackling what the Industrial Ontology Foundation also wants? Is there synchronicity in our aims? I'm sure there is, because we're after the same thing. Something that can be shown as a recipe at home, an industrial formation at some level of detail in the lab or factory. Okay, so circling back on semantic granularity, the approaches to setting up object properties, whether we're using a sort of general relationship between an entity or very detailed ones. So shortcut relations, often introduced in advance. I already covered this. So modeling is required for computational equivalency. So what I'm hoping is that in our work looking at new relationships that we might need, that we can maybe find the shortcut through the more complex model underneath, or at least see our way to that future in RO, say, using RO relations. And if not, we'll have to add them. RO is getting new relations every couple of months or month. And you'll see that they're kind of trying to tackle concepts that are outside of the material processing area into the world of human affairs, or more abstract concepts like nesting, is nest of, is habitation of, relations that are kind of hard to imagine creating a whole process model around. So, and just to finish with the example of has age. One database is has age, the same as someone else's has age. Well, is it about humans? Has age of human? The tree rings? Or that's how, is it about trees, other organisms? Is it measured in tree rings? Is it from the point of birth or of conception? Has age itself is almost meaningless unless it's the classes at either end of that relationship that are constrained and defined. And then the fact that this has age is actually a duration, not just a number, but a span of time between two events or two measurement points. That's the kind of granularity we need to take any relationship from the outside world and decompose or bring out the implicit assumptions. So just say again, specialized language, Dale's cognitive load, learning ramp, memory strain. Wikidata now has 9,000 relationships. Which ones of those are pertinent to food processing? I don't know, or processing in general. Confusion about cross-domain pertinence, the need to map those relations. And a roadblock to federated knowledge. Every time we come across this, now we don't know whether we can map and have to figure out what the underlying model is. But the pro is that one goes to these quick relations just for simpler graphs and sentences. Is that the last slide? Yes, it is. Good. So just to get into the technicalities a bit. So SOSA has made observation, made sampling, made actuation relations. So if you have a SOSA made observation, you can bet that the Y in that triple is an observation. But if you're to convert that into OB land, OB vocabulary, we would say select some, in this case, sensor X, and has specified output, some Y. Then we'll have obtained the same information, unless sensor X is outputting some other things besides this kind of output, in which case we do have to distinguish as well that we're looking for an observation of the sensor output. So there's a little bit more sense and complexity in our queries, although the relationship and the knowledge graph structure is just the same. We're having to put more constraints on what's at either end of the relationship if we're adopting general language. So I get that and so having this SOSA made observation is totally valid out there in the world for other knowledge graphs, but now we need this transform to get to the general knowledge. And that brings us to the end of the crash course. So let's talk more about this. Questions? Hopefully I haven't.
Yeah, Damien, I'll jump in. Talk to me about sub-process. So what I see in here is that process is recursive. Processes can be comprised of other processes, and that's how you get so-called sub-processes. Magali is going to tell us later about a process having steps, which I think is the same general idea. It seems to me that in the world of food, we may want the process to be connected with different ideas from the sub-processes. Like the whole script, if you will, the recipe is conceptually different from the individual actions. Yeah, exactly. And so to some degree, the recipe inherits things from its sub-process. Ingredients are example one. In some cases, not. What does OBO have to say about all this?
OBO hasn't said anything. Nobody, as far as I can tell, has done any example modeling of component processes, elevating up their and combining automatically their objective specifications, their planned specifications, their step action specifications, which are steps, step and action are kind of the same thing. They haven't done it. So it's up to us. This is our pioneering work to demonstrate this. And I am going to write in the next week just a presentation for the food IFAO in Sherbrooke in 2 months. And it will just talk about the difference between expectations around a process model like this one here, where you're just looking at this framework and it's explaining everything kind of programmatically about what has to happen when, but there are no visible lists here of plan specification and objective specification and action specification. This is the program, so to speak, rather than the instructions to get you to this program. So now what we have against this 100% process model is the needs on the other side, cultural, informational, follow instructions needs, where we got documents describing the steps that are necessary to anticipate or do all of this sub-process activity. So I see great need to translate in one direction and the other, both ways, between the two, and that's what the presentation would be about.
Cool.
Just sort of schematically. So every one of these process boxes could be taken on its own separately, and have all its needs specified in little objectives and so on. Can we digest all of that back up into information documents that say, the first step is to add liquid, the next step is to heat it, based on looking at this informatic diagram, or vice versa.
So, my turn. Just to ask a little bit more, what about the time relation? Because here you speak about a document specification, a specification of a document to specify the sequence of sub-step or steps.
Yeah.
Which are in fact processed in OBO Foundry, but let's say it is the same thing. But what about the link to all time? I don't see it in your diagram. So
right, implicitly every blue purple box has time, some owl time. So you can specify necessary minimum durations or maximum durations. You need to cook the eggs for 3 minutes, or you need to let the rice cool a maximum of 10 minutes or something. All of that's not mentioned here. We could add.
Yes, but you mentioned duration, but what about the instance when the process starts and when the duration doesn't give the information about the beginning and the end. It is only the duration. So do you also have the moments, the time, the instance?
So recipe talks about durations, necessary durations.
Yes.
But doesn't mention stop and start times. An instance of a recipe, an actual following of a plan specification, drops this class level thing down into the instance world. And that's where I'm starting this recipe at 9 a.m. So I actually set times in the either in the protocol or just in the instance of what I'm working on. Now we can work out, or I'm sure we can work out, maybe not through OWL, because of the problem of reasoning stuff there, dependencies, but we can work out through some other language, swirl or whatever, we can work out that this process for heating can only happen after you've added the liquid. And so there's a time dependency there. And we don't need to expressly state that. It can be worked out programmatically, because these are dependencies right now. These are not parallel processes, though our process diagram could have parallel processes, and then that's also a desired outcome, to show that chunks of them can operate independently time-wise.
So if I understand correctly, sorry, you are saying that you have some dependency. This dependency are expressed by rules, by some rules or constraints, or is it only with time? I don't really
Okay.
use it.
So this relationship between heating liquid in container having primary input, some drinking water, and an instance of this being the output of adding liquid to container is the dependency, is the stepwise dependency of these two things. I don't have to say anything more than that.
Okay.
In order to ensure that all of the time dependent stuff falls forth. So you will see out there in process modeling, some people will jump straight to expressing time dependencies. But here we're leaving that to be a secondary outcome of the step, expressing the step dependency.
It is because of the relation as primary input.
Yep.
And then as
or
yes.
has input. This primary thing, I was just toying with that. It's an actual relationship in RO, but it could just be has specified input, by the way.
Specified input or specified output, because when you say a relation between two processes, it is a relation, a different relation. It is not, every processes are not always linked by through components, input and output component, but can be linked directly with your directly provides input for.
Right.
You don't mention the component here.
This is a shortcut. This is actually a shortcut relation. It's this means there is an entity which this is an output of and an input to. So
yes, yes, you have spoken about shortcuts, but I don't really grasp them.
That's
yes,
it.
okay.
Like I could have said provides direct input to here, but this is equivalent to that.
Okay, thank you.
Okay, Robert, we're going a little
just
over.
To make sure,
Fine.
Just to make sure I'm tracking here, from just a practical sense of this, where is the recovery time from when you add the carrots to actually getting back to boiling? Because the water is at a certain temperature, 100. You add the carrots, and depending on the temperature of the carrots, the size of the carrots, and that's...
Glad you're on my case on that. So I'll skip out of this. So that's showing up in the process modeling paper.
Okay, so that's coming. That's coming. I'm just making sure that I'm thinking it through all the way to that stage.
Yeah. So adding solid, semi-liquid with solid pieces, heating liquid in container because we have to get it back to the boiling state. Now we've got a boiling mixture, different from boiling water. Boiling in container means that we need to see this mixture back at boiling temperature. And so that would be what you're talking about, back to the heating liquid in container process. So I'm envisioning that we are able to describe each of these processes independently in Foodon, hopefully, and then be able to, like Lego bricks, plug them together and get all of the necessary dependencies. And as a side note, this process is only complete when this thing called boiling mixture has been attained. So we need sensors of some kind, whether you're listening to bubbles popping, that's a sensor, or a time, a pre-configured amount of time, we know it's going to be boiling at that time. It needs to be measured to be its attainment, and it won't be a boiling mixture until certain characteristics have occurred. That's where we get into that feedback loop thing where yeah, that's where we get back into maybe adding on the sensing process and feedback loop. about when something is
Right.
completed.
And just two last things, and we can get to this later on. And so it also seems like these words that you're using, boiling, simmering, sometimes there's a range of temperature. It's not a specific exact temperature, as well as the size of the carrots and how they're cut. And then getting into, which is even further, what carrots don't all boil the same. Depends on the carrot. But that's
Yeah,
another story for another day. The
right.
density, just like fish doesn't cook at the same rate, salmon to sturgeon, drastically different because of their mass.
Exactly. So we're getting into monitoring different ways of calculating completion of a task.
Okay.
Uh,
Okay.
There's a temperature. Oh, right, that's in the other paper. Anyway, there's showing how boiling water at 1 atmosphere is a certain condition. That's a class of things
Okay.
defined, but boiling water actually has one instance. And it could actually be that we set up basically just like SI has the 1 kilogram stored away in Paris. It's now a digital, they're all defined digitally, but for a while in the old world, was that a representative kilogram of mass and a representative meter upon which all other meters are based. We can do the same thing in the digital world by defining in Foodon or wherever boiling water as an instance of boiling water as at 1 atmosphere, 100-degree temperature water. But that leaves what boiling water could be defined at 1 kilometer up in the atmosphere, given
Right.
the
Okay. Thank you.
Okay, any other interesting stuff? Feedback? I guess what I would say is, I know people are working on different projects. They're not necessarily within OBO Foundry. So what I hope this does is provide context about what, if you need something and it's not covered in this OBO Foundry model, what is it in terms of relationships or entities? Energy, for example, OBO Foundry does not know how to deal with energy consumption, boiling a pot of water as an input to a process. So we'll be breaking new territory talking about energy consumption. Okay, if not, then join us in 2 weeks for Magali's deep dive into relationships, as I understand it.
Yes, and just to be sure, should I detail the SOSA, so PO2 model with the link with to SOSA, or what do you prefer?
So this sort of touches on what's the mission of the group, so which we get to define. But I know from Foodon's perspective, what do we need to capture within OBO land that and what I'm expecting from your presentation is that it will raise discussion about how Foodon should mirror in order to be a translation vehicle for all this FSA, FoodX2 stuff, say, or the processes found there, other kinds of food safety, security, or production.
Yes, in other way, should I modify the presentation I made for the...
I was thinking you've got 2 things going on there, the choice of relations with SOSA and
yes,
and you got the real world view of how much momentum those ontologies have and what they're good at describing. And then you've also got the content side, which is the FoodX2 class of food processes.
Yes, okay.
So we need to deal with both of those over on the Foodon side. So it would be helpful to have content on both those areas, but what you definitely need and what's good, what's inherently good about certain structures there that we should try to emulate.
I will try to do so. See you.
Okay,
thank you, Damian. It was super clear and even if I have already participated in the paper, I'm always learning more. So thank you.
Shucks. Good. Well, I hope I'm also in that camp too. Okay, so great. We'll reconvene in 2 weeks, and thanks all. I'll have the video up, by the way, too, to share.
So bye-bye.
Bye.
Thank you.
Thank
Bye.
you. Bye.
Thank you. Have a good day all.